Welcome to a video on evaluating a piecewise defined function and graphing it. We'll begin with finding f of 0, f of 1, f of 2, and f of 4. So to evaluate f of 0, consider the input of that function. The input is 0, and now we need to look at the condition on the function and see which piece it satisfies. Plugging x into the first piece, notice that 0 is less than or equal to 0, making that condition true. And therefore, we would evaluate the function using the quadratic piece, which is negative x squared. So that would be 0 squared, and then negating it, which still remains a function value of 0. For f of 1, again, we need to consider the input value of that function. So looking at these restrictions on the function f of x, notice that 1 here is not less than or equal to 0, but 1 here is in between 0 and 2. So making that second condition true, which means that we're going to evaluate f of 1 using the second piece of the function. The second piece of the function is a constant value 1. There's no x there, so its function value is the constant 1. For f of 2, likewise, consider the input of the function, which is 2. Again, plugging 2 into the restrictions of f of x, 2 is not less than or equal to 0. If we plug in 2 to the middle piece, 2 is not in between 0 and 2. And also, 2 is not strictly greater than 2. So with f of 2, this does not satisfy any of the restrictions on that function f of x. So its function value is undefined. Finally, f of 4, the input value is 4. Again, 4 satisfies the third restriction of the function f of x. So we're going to use the linear piece to evaluate. Hence, negative 3/2 times 4 plus the number 4. And reducing this and simplifying, we get negative 6 plus 4, which is a function value of negative 2. Now we're going to move on to graph the function f of x. So we'll start with the first piece. Let's go ahead and consider that as y1, which is negative x squared, provided that x is less than or equal to 0. So to graph this equation, y sub 1, we can use a t-table or just plug in values of x within its restriction to get a few points. We can begin with substituting in the value 0. So the square of 0 is 0, negated, which is 0 again. So again, notice that based on the condition of this equation, x has to be less than or equal to 0. So this is the furthest right-in point of the graph of this equation here. So we don't want to substitute in any values greater than 0. So the next one would be, say, negative 1. The square of a negative 1 would be positive 1, but negating that at the end gives it a negative 1. Again, let's pick another point that's less than 0. So let's say negative 2. Negative 2 squared is 4. Negating the 4 is a negative 4. So here's another one. Now, if you recognize the graph of the equation y sub 1, notice that it's basically a parabola that opens downward. But again, based on the restriction on our input values, it's only half of it. So there's the first piece of the function f of x. For the second piece of the function, let's go ahead and call it y sub 2. This is a constant function where its input has to be strictly in between 0 and 2. So strictly greater than 0 and less than 2. So y equals 1 is a horizontal line at 1. Again, we only want to consider the part where x is in between 0 and 2. Now, at its furthest left endpoint, which is at 0, we have to use an open circle there because it's undefined at that point. And we want the segment from 0 there to the value 2. Again, at 2, we want to include another open circle. So for the second piece of the function, this is its graph. For the third piece, we'll go ahead and call it y sub 3, which is a linear piece with the condition that x is greater than 2. To graph y3, I'm going to ignore its restriction for now. And that's because to graph a linear equation, it's best to start with its y-intercept, which is 0, 4, and then use the slope there to obtain another point. So starting with 0, 4, the y-intercept, the slope there is negative 3/2, which is defined as rise over run. So we're going to go down 3 units from the y-intercept and then run 2, which gives us this point right here. So let me illustrate this in a different color. So start at 0, 4, down 3, run 2, which is going to overlap this open circle here. Again, we're going to apply it one more time. So down 3, run 2. And with these 3 red dots, it's more than enough to sketch the line. Okay, now once you have the line, we are now going to consider the restriction on its input values. So this is only true for x greater than 2. So at this point, we want to use an open circle. So I'm going to remove that red dot. And then we want all the values from there to infinity. So I'll connect that open circle to the next red dot. This one I can remove now that I have the line. And there it is. So together, these 3 pieces form the graph of the function f. Let's consider the last part of the problem. It says to evaluate using the graph. So this is basically verifying that these 4 function values are defined correctly. So we'll start with f of 0 using the graph. F of 0, when x is 0, the output there is clearly 0. So this checks off. F of 1, when x equals 1, the output value there is a 1. That checks off. And when x equals 2, notice that at 2, there's an open circle. Therefore, the function is undefined there. And finally, f of 4, when x equals 4, here's the output value, which is negative 2. So this checks off as well.